establish that result, 2 the square root of 7 times the square root of 7 is 2 times 7. 2 times negative 2 is negative 4. The square root of 7 times the square root of 5 is the square root of 35. Are these steps clear? I multiply this by this and this by this. Yes? Now I reached the second term. 3 times the 1 outside is 3. The square root of 5 times the square root of 7, the square root of 35. Final step. 3 times negative 2, which is negative 6. These are outside. But I know now that the square root of 5 times the square root of 5 is 5, so I'm going to say times 5. So this is 14, but this is negative 30. And these are like radicals. I can combine them. Negative 4 plus 3 is negative the square root of 35. And here I have negative 16. So negative 16 minus the square root of 35 is the simplified form of this product. Do we agree with that? Every step? Is that clear? Okay. Let's do one more. And then we're going back to our contract. Yes, that's why I discussed it from the very beginning. 68. 5 the square root of 7x minus the square root of 2x multiplied by 4 the square root of 7x plus 6 the square root of 2x. This is a little bit more involving because it has x in it. So let's give it a shot. 1 minute. And remember the result. And we assume everything positive. Do we need more time? Okay. Okay, ready? Okay, so I have 5 times 4, which is 20. But I know now the result, this is definitely 7x. Then I have 5 times 6, which is 30. And I know that the square root of 7x times the square root of 2x, we can write it, is the square root of 14x squared. But I know that this will come out in a minute. then this times this, which will be negative 4, the square of 14x squared. And then I know that negative 1 times 6, so this will be negative 6 multiplied by 2x. Under the condition that everything is positive. Otherwise, I have to use absolute value. Okay, now this is 140x, and this is negative 12x. These are like radicals, and I'm going to write 26, the square root of 14 times the square root of x squared. So this will be x, the square root of 14. Finally, I combine these two, and I get 40 minus 12 is 28. So 128x plus 26x, the square root of 14, is the very final step, and I cannot do anything else. They're not like terms, cannot combine them. This one does not have the square root of 14. I can't do anything else. Yes, you could factor out. There is no need. Now, this is what I'm interested in. But we had to build all this before getting to what I'm going to write next. You had to see a few examples. Okay, and here it is. 65. The square root of 3 plus x. And as I mentioned before, yes, you can FOIL. Please don't, though. Let's use the agreement we have. That's the reason why it's so important. It's throughout the entire course. So this is like my A, and this is like my B. So when I square A plus B, how many terms do I get? Yes, indeed. And they are the first term squared plus twice the first term times the second term plus the second term squared. That's why I tortured you with this from the very beginning, quote unquote. So now, can you please give me the expanded? This is extremely important. This is one of the most important topics here in the first 4 sections. Be able to square an expression like this. And we cannot get 2 terms. We must get 3 terms. This is a sum of 2 terms squared. So, the first term squared plus 2 is outside. Has to be multiplied by x first. So 2 times x times the square root. Because 2 doesn't have a square root, x doesn't have a square root, so these have to be outside, and then the radical. So what will be the next term then? 2x the square root of 3 plus, finally, the second term squared. That's it. No one can simplify this. This is it. Yes, Becky? Yes, we are still in 10.4. Yes, yes. Any questions on this? No, I need to practice that. Please make one up. Anything that you want. Let's say x the square root of 7 plus the square root of y. Let's work on this for 1 minute. Can anyone give us the first term squared?
X squared.
Excellent. plus. Remember, there is a 2 outside, and there is an x outside, and then the product. Very good. Indeed, 2x times the square root of 7y. Excellent. Plus, and we know the result. I take this. I square the second term. What do I get? That's it. This is very useful for what follows. But I would like to look at two more examples. Here's one example. Still, the contract is valid. You'll see in a minute what I'm talking about. Again, I don't want you to FOIL. I have no way of preventing you to FOIL, just begging you not to FOIL. Because it's more important to remember what formula this is or special product. It's a plus b, and then exactly. And the result would be a squared minus b squared. Very good. So the result, as you said, Matt, what would it be? 3x minus 4. Yes, indeed. Okay, I want two more, and then we'll move on. I want 75 and 74. Let's start with 74. The square root of 3x plus 1 plus 2, everything squared. We're back to that first situation. Careful. Please do not FOIL. Can you? Yes. Will you get full credit? Yes. But you will not advance with everyone else if you do. The first term squared. Remember the result. The first term squared is very good. Plus, careful now. 2 is outside. There is a 2 without a radical, and then a radical. So 2 from the formula, 2 as the second term, and the radical. What would you write as the middle term? Four square root of 3x plus 1. Finally, plus the second term squared. 4. The only thing we can do is add these two, nothing else. There is nothing else we can do here. So this equals 3x plus 5 plus 4, the square root of 3x plus 1, and this is it. I think we should work on one more problem, as I said, 75 or any other, like this one. So 75. So let's work on this for a minute. 2x plus 5 minus 1, everything squared. And you will see where I need this in the next 10 minutes. I need this result. And again, I'm going to kindly ask you to not to FOIL, if possible, but use the special product. Can anyone give us how many? Well, so for example, here I said 3 terms because from here I will get 1, the middle term and this. But it turns out that since it's 2 terms, I have 1, 2, 3, 4. But never to assume that a binomial squared is 4 terms. It could be, but initially it has to be 3 terms. Okay, because of the radical. Okay, can anyone give us the answer for this? Becky, go ahead. Very good. Yes? Yes. Very good. Excellent. Do you all agree with this? Wonderful. The only thing I can do is this and this. Combine like terms, nothing else. So 2x plus 6 minus 2, the square root of 2x plus 5. I have to say that this is not trivial. I do not consider, that's why I'm doing so many. I don't consider this trivial at all. Okay, perfect. Now we're finally in 10.5. Nothing new. We already discussed everything in 10.5, which deals with rationalizing denominator. Denominators, and it can be numerators. We will be asked to do that also. And in the next section, I'm going to use exactly what you see here. So I just want to practice a little bit because we haven't looked in the book at all. So, for example, let's say 28 on page 622. The cube root of 3x over the cube root of 4y to the 4th. Do not write this because this is not what I'm going to do. I am tempted to do this because I'm allowed to. It's correct. Nothing wrong with it. Why? Can anyone explain why I'm not going to go this route? It's not wrong, but it will not help me for what I'm trying to do. So the question is asking us to rationalize the denominator. That's the question. Why am I not going to go this route? Because I cannot simplify. 3 and x and 4 and y are not common factors. This will not help. So what I'm going to do, though, is simplify the radical in the denominator, which is not simplified. This is 2 squared, right? So the cube root of 2 squared is simplified. But the cube root of y to the 4th is not simplified, right? Okay. So the cube root of 3x stays. How do I split the radical in the denominator? I have the cube root of 2 squared. I have to write it like that with prime numbers. And I also have the cube root of and the cube root of. What am I getting at?
Y.
Exactly, as we know, y to the 3rd and y. I claim that from these 3 radicals, only 2 need to be rationalized. One of them doesn't need to. Which one does not need to be rationalized? The middle one, right? Because this is just y. So I'm going to rewrite the cube root of 3x. I'm going to put y in front. And what I have to rationalize is this. What am I going to use in order to rationalize this denominator? What index? What do I have to do?
Your index is 3.
Absolutely. I will not be able to multiply, of course. And remember, the index is the dictator here. How many 2's do I have?
2.
How many more do I need to form 3?
1.
Exactly, as we did last time. How many y's do I have? But I need to have a total of 3. How many am I missing?
2.
I'm missing 2. The numerator is very clear. There is nothing I can do to it. I just have to write it as the cube root of 6xy squared. I multiply the cube root of 3 by the cube root of 2. I get the cube root of 6, and then x, and then y squared. Now here, I know what this is. I made it happen. Forget about this for a moment. What is this? It's the cube root of 2 cubed y cubed. So what could this be? And 2. Right? The cube root of 2 is 2, and the cube root of y is y. But now I have to multiply the y in front by the 2y, and I'm done. Squared. And that's it, and that's final. Any questions on this? Let's look at 26. After this section, this chapter becomes a little bit more interesting. Right now, we're just dealing with all these rules. So 26, 1 divided by the square root of 32x. Again, the same question, we're asked to rationalize the denominator. I highly recommend fully simplify the denominator and only rationalize the portion that needs to be rationalized. I don't recommend you multiply top and bottom by the square root of 32x. I don't recommend that, because then you have to go back and still simplify it. Why not simplify it from the beginning? We know that the square root of 32x is not fully simplified, as it is. How will you split 32? Into, yes, because the index dictates. So this is 1 over the square root of 16, the square root of 2x. And I know exactly what needs to be rationalized. So I'm going to rewrite 1 over 4, the square root of 2x. And now I know which portion needs to be rationalized. I'm going to write it again. 1 over 4, the square root of 2x. So what does this need? The index is 2. I only have 1, 2, and I only have 1 x. So it's going to be the square root over the square root of what? Yes, 2x and 2x, right? Because 2 times 2 will be the square root of 2 squared, and x times x will be the square root of x. So the numerator is the square root of 2x, and the denominator is, this is our 2x multiplied by 4. Well, let's also look at the other type of rationalizing. Like, for example, 52. And again, I could have not done this without that agreement with you from the very beginning. We're asked to rationalize the denominator. Again, we have to go back to our agreement. What are we going to use? Which special product is applicable here? I can square, so it must be the third one. So what do I need? Exactly, the conjugate. Very good, excellent. Please do not FOIL the denominator. Can you? Yes. Please don't. It's more important to remember first term squared minus the second term squared. That part is more important. So, what do I write? When I square this, what do I get? That's it. Minus, when I square this, I know the result now. What do I get? That's it. Now the top is more difficult because I have to distribute. Or not. But sometimes I will be able to simplify, sometimes not. So you can leave it as 2 the square root of a distributed, or I'm sorry, quantity to the square root of x plus the square root of y. You can. I'm okay with that. But sometimes distributing makes things easier in these situations. Okay, let's look at one more. They all seem very similar. Okay, yes. Let's say the square root of x, that's 82. And this time we are specifically told to rationalize the numerator. That's okay. So let's say we are specifically asked, and sometimes we will rationalize the numerator for simplifying expressions. So that's very possible. What would you multiply top and bottom by to rationalize the numerator? Becky? If I put plus, you're talking about the denominator? No, we want to rationalize the numerator. So look at the numerator and tell me what your minus. Very good. You're right. Perfect. Excellent. Good. I highly recommend use our special products and our contract for both. The top is easy. It's the first term squared minus the second term squared. The denominator is more involving a little bit. So the first term squared, x, the square root of x squared, which is x, yes. And then minus the 6, yes. Now here, notice that these are the same. So the first term squared minus, because it's minus, 2, it's outside, times the square root of x times the square root of y. The square root of xy plus the second term squared. Now this will be a terrible mistake. Terrible mistake. Horrible. Why? Can anyone explain why? Because these are terms. This is a term. This is a term. This is a term. This is a term. I'm not allowed to simplify terms. I can only simplify factors. So that would be a terrible mistake. So I'm going to write it one more time. So the answer is x minus y over x minus 2, the square root of xy plus y. And no one can simplify this. I know I have 14 minutes left, so we can start the next section, which is radical equations. This is it. This and one more. Okay. It doesn't mean that the test is going to be next week. No. On Tuesday, I'm not going to be able to finish tonight. On Tuesday, we're going to finish, and we're going to go back and review everything in Chapter 9 and everything in Chapter 10. Tuesday and Thursday. So the test will be a week from Tuesday. If anyone can give me a date, I can't think right now. So it was, what was, today's the 5th, the 3rd, 10, 17th. Is that, am I correct? Is 10/17 a Tuesday? Okay. So this is going to be our test 2. But I need next week to finish and about 3 hours to review everything. Okay? So this is our tentative schedule for test 2. If we need more time, I'll allow more time. So, but that's our target. Okay. So 10.6, radical equations. I'll go back to the handout. So these are the last 2 pages. And we're talking about the principle of powers. I have to talk about the principle of powers, and then we'll look at the rest. Okay? And this is the square root property that I needed to use earlier. So these are some problems that I selected there. That's what we just discussed. So I have to talk about equations, and then I have to talk about complex numbers. And that will be the end of Chapter 10. Okay. Now, I'm not in a rush. I don't have, finish. We can finish on Tuesday. But here's an equation for you. I'm going to ask you now, is this solved? Is there anything I can do to it? No, it's already solved. It's x equals 2. There is nothing simpler than that. Okay, bear with me. Let's say, for whatever reason, and I'll explain the reason, but not for this equation though. But let's say for this equation, I want to raise both sides to the second power. So let's raise both sides to the second power. But the result is a quadratic equation, right? Which I know has two solutions. So I started with x equals 2, and I ended up with x squared minus equals 4 when I squared both sides. But what are the solutions for this equation? We solved it with taking square roots a few minutes ago, or an hour ago. How many solutions did this one have? 2, right? X equals 2 or x equals negative 2. So what is the point I'm making here? First of all, you can say, you're not even talking about radical equations. True, I'm not yet. I agree. This is not a radical equation. This is a linear equation. This is quadratic. So how does this connect to this? Bear with me. So the point I'm making here is that if for whatever reason I decide to raise both sides of an equation to a power, I have to be aware of the fact that I may get solutions that do not work in the original problem. So this is not a basic principle of equations, meaning if I add 5 to both sides of an equation, I'm not changing the solutions. If I divide both sides by 10, both sides of an equation, I'm not changing the solutions. If I multiply both sides by 10, I'm not changing the solutions. If I divide both sides by 15, I'm not changing it. So if I move x from one side to the other, I'm not. But if I decide for whatever reason to raise both sides to a power, I have to think and say, oops, I'll do this. But at the end of the day, I have to check solutions in the original problem. Mandatory. It's part of the problem. If I employ this procedure, I have to, at the end, check the solutions in the original problem. So here I will say, this is okay. This is not. And I will say this is called extraneous solution. Something that it's a byproduct of what I'm doing, but does not work in the original problem. So I do have a few more minutes. Let me show you an example. On page 630, and this is called the principle of powers. I'm raising both sides to a power. Principle of powers. Okay, so let's say a problem 8. The square root of x minus 3 minus 1 equals 0. Now, of course, I'm going to ask you to solve the equation, but I'm going to ask you what type of equation is it? Is it linear? Is it quadratic? Or is it radical? Now this one is radical. Okay, how many radicals does it have? I need to isolate the radical. Mandatory. Okay, how do I isolate the radical? Right? And now I'm going to think, how do I get rid of this radical? The square root is what power? What is the fraction that represents power, the square root? 1/2. So should I raise both sides to the third power? Should I raise both sides to the second power? Should I raise both sides to the 7th power? Which power do I raise both sides to eliminate the radical?
2.
Exactly. Because the radical is 1/2, I have to raise both sides to the second power. Excellent. Good. What do I get on the left-hand side? I know the result. When I square a square root, what do I get? What do I get on the other side? So then, now this is linear. And I know that x equals 4. But it comes with a big question mark. I have no idea whether this works in the original problem. No clue. It is part of the problem. Because I know when I raise both sides to a power, I may get extraneous solutions. Solutions that have nothing to do with the original problem. Like this one. This one had no sense here. Nothing to do with it. I cannot consider this a solution. So then I go back to the original problem. I replace x by 4. 4 minus 3 is 1. The square root of 1 is 1. 1 minus 1 is 0. I checked, and I'm going to say yes. This is the application of principle of powers. I promise one more example, and I'll stop. It's a lot. We accomplished a lot. 2x plus the square root of x plus 1 equals 8. Again, I'm looking at this. Somebody gave me this equation to solve, and I'm looking at it, and I'll say, oh, it's radical. Second question I ask myself is, how many radicals does it have? Right. So I will have to isolate the radical. So in order to isolate the radical, I will have to do what? Good. Now I'm ready. Ready for what? Ready for eliminating the radical. Now the question is, since the radical has index 2, because it could have had 3, it could have had 4, since it has 2, what do I do to both sides in order to eliminate the radical? Square. The principle of powers. However, the principle of powers is not a friendly principle. It's very useful and the only chance I have, but it's not a friendly principle. I have to go back and check. The left-hand side is easy. What is it? But the right-hand side is a contract. If I write two terms, I'm in big trouble. So what does the right-hand side equal to? First term squared. See how I can go get around this. Okay, 64 minus 2 times 2 is 4. 4 times 8, 32x plus the second term squared. That's it. Now I look at this equation and say, oops, now this is what type? Very good. How do I solve a quadratic now? I have 4x squared. I have to set it equal to 0. I have to subtract x. And I have to subtract 1. To set it equal to 0. It's a quadratic equation. I have 4x squared. I have to subtract x. So I have negative 33x. And I have to subtract 1. And I get 63. Now this is a big deal, because I have 4. And I have 63. And I have to find two numbers whose product is 4 times 63. I'm not going to bother multiplying it. And I have to find two numbers whose sum is negative 33. What I'm going to do, if I find my calculators, my calculator, the one that I like very much, and for some reason they don't produce this anymore, I haven't seen it anywhere. It's an 86. I think it's way better than 84. So what I'm going to do, because again I don't want to hold you, only have 3 minutes, and we have to find those numbers and then go back and distribute and use factoring by grouping. But I want to show you why I like this calculator so much, because it has a feature that is called polynomial. So I press on the yellow, on second key, and then poly, and it's asking me, the calculator is very old, so it says order instead of degree. Well, it's 2. Degree is 2. Now it's asking me for the coefficients, the leading coefficient, the middle coefficient, and the last coefficient. So I'm going to put them in as 4, negative 33, and 63. So 4, enter, negative 33, and 63. And I'm just going to press solve. It's going to give me the answer. So one answer is 5.25 and the other one is 3. And we can do this by hand next time, but I just don't want to hold you over. So x equals 5.25 and x equals 3. And just, I'll bring this and we'll continue it. So now the question is, if these work. I have no idea. I cannot say that these are solutions. I can say from the process of raising both sides to a power, I got this. But who knows whether they work or not. So I have to go back to the original problem, 2x plus the square root of x plus 1 equals 8, and check them. So I will check 3 first. Let's say 3 and 3. 2 times 3 is 6. 3 plus 1 is 4. The square root of 4 is 2. Is 6 plus 2 8? Okay, so I'm going to say yes to this one. But then I see that 5.25 is not going to work. Because when I write 5.25 and 5.25, 2 times 5.25 is more than 10. Plus a positive number. I know the square root is always positive. So 10 plus a positive number cannot equal 8. So that's why I will cross this out and say no. That is that byproduct that I may get sometimes that does not work in the original problem, called extraneous solution. Any questions?